Welcome to All This Math. This is Professor Parker, and today we're going to do some geometry. So here we have a word problem, okay? First thing is, with word problems, do not get intimidated. Word problems can be translated into a mathematical statement or mathematical sentences or algebraic equations, and then you can work them out. But you do have to know how to do the translation. You have to know how to translate from all of this into some equations. And once you translate all of this into an equation, then you can solve the equation, and then you'll have the answer. And then also you can check your work to make sure your work makes sense. But the first step is to actually read the word problem and really understand it. All right? So this says that a cylinder and a sphere have the same radius and volume. So when you're dealing with word problems, you probably want to go through and underline or highlight or draw circles around or box in important information. So I know I'm dealing with a cylinder, and I know I'm dealing with a sphere. Now, in case we're unaware of what those shapes look like, a cylinder basically looks like a pipe or a soda can. All right? So this might be like a cylinder might look like this. I'm not really good with these drawings, but yeah, a cylinder might look like that, right? But just think of a soda can. Like if it was 3D, it actually would look like a rectangular prism if it was 3D. So the cylinder looks like a soda can when you're looking at it straightforward, right? And then a sphere is just a ball, basically. That's all a sphere is. Basketball, soccer ball, baseball, volleyball, dodgeball, whatever. Now, what are we saying though? In fact, let me do this. Yeah, 3D. There you go. Sphere, cylinder. Now, we end up talking about the radius and the volume. Now, the radius is the measurement from the center of any circle to the edge of the circle. All right? That's all the radius is. So we need to know what a radius is by definition. And we also need to know what volume is. Now, we're not talking about how loud something is. We're talking about the amount of space inside of a 3D object. So the volume represents the amount of space inside of this ball or this sphere. The volume represents the amount of space inside of this cylinder or this soda can. And we also know that we're talking about the radius. The radius goes from the center to the edge like that. And then since this is actually circular, but you can't see it from this angle, the radius goes from here to there. All right. Now, according to this problem, the cylinder and the sphere have the same radius and volume. Now, of course, it doesn't look like that from the picture, but the picture is not drawn to scale. All right. We always default to the information that's in the word problem, not necessarily what the picture looks like. There are certain things that we can assume and that we can default to what the picture looks like, but most of the time we default to the information that's given because these pictures are just not drawn to scale. They're not drawn properly. All right? But that doesn't matter because the math will still work out. So I keep reading and I see that the height of the cylinder is 12 centimeters. So what I'm going to do, I know that that's important information. So I'm going to underline that. 12 centimeters, and the height. Now, the height of the cylinder, not of the sphere, but of the cylinder. So that means that it's 12 centimeters from here to here. That's 12 centimeters, all right? And then I'm going to also write that down somewhere. I'm also write height cylinder equals 12 centimeters, okay? Now, the question is, what is the volume of the sphere to the nearest whole number? Now, we also need formulas. We need formulas. We have to have formulas. There's a formula for the volume of a cylinder. There's a formula for the volume of a sphere. All right? Now, why is that relevant? Because this problem talks about the radius and the volume. So what you need naturally in any problem like this, where you're talking about the volume, the area, the surface area, the perimeter, the circumference, anything that requires a formula to calculate, write that formula down. And when you get in the habit of writing formulas down every time, eventually you'll memorize the formulas. So check this out. The formula for the volume of a cylinder is pi r squared times the height. It's basically that formula for the area of a circle times the height. Because really all a cylinder is a bunch of circles stacked on top of each other. That's all a cylinder is. A bunch of very thin circles stacked on top of each other. And I know if I find the area or the amount of space inside of a circle, which will be two-dimensional, I would use this formula, pi r squared. But then because there's a whole bunch of them, I represent that by multiplying by the height of the cylinder, because that height represents how many circles it is. And we have 12 centimeters worth of circles. So the volume formula for a cylinder is pi r squared times the height. And then for a sphere, what's the volume of a sphere? Volume equals 4/3 pi r cubed, or to the third power. So all the space inside of this sphere or this ball can be calculated by multiplying 4/3 times pi times r to the third. All right. Now, we need to set up an equation. So now you got to be able to go into this word problem, read it, understand it, and then translate it. Because understand, mathematics is a language. It's not even like a language. It is a language. Math is a language. And just like we translate from one language to another, we might translate from English to Kiswahili. We might translate from English to another West African language. We would translate this word problem into the English language, into a math equation right now. So it says that they have the same volume. All right. Now we're going to deal with the radius in a minute, right? But they have the same volume. So I know that I'm going to do this. I can do, because the volume of this is equal to the volume of this. So that means that I can set this equal to this. Right? Now see, you writing this down? All right. I can set this equal to this. So I got pi r squared times the height is equal to 4/3 pi r to the third. Now the reason that makes sense is because they have the same volume. So that means the number that will go here is the same as the number that will go here. So if these numbers are the same, then that means that the value of this has to be the same as the value of this because of that equal sign. That's what the equal sign means. For example, if the volume was 20, that means that this is equal to, these numbers multiplied together have to equal 20. And if this is 20, and if that was 20 at the same time, that means the value of these numbers multiplied together would have to also be 20. So that means that these two values or these two expressions would have to be equal to each other. They have to be. All right. So this is our equation. So now we can say, all right, what other information do we know that we can use in this formula? I know that the height of the cylinder is 12 centimeters. So that means I can rewrite this and replace this h with this number, 12. So now I'm doing pi r squared times 12 is equal to 4/3 pi r to the third. Now again, if you're ever in a mathematics class and your teacher writes something on the board and you don't understand where that number came from or why there's a difference, you should raise your hand and ask. So for example, you should understand where this 12 came from, because up here in this step, there was no 12. So you should be asking yourself, okay, everything else is the same except for that 12. Now, where did this 12 come from? It came from the fact that we know that the height of the cylinder is 12 centimeters. So therefore, we can replace this letter H, which represents the height of the cylinder, with the number 12. All right? So now, what we're going to do is, in order to find the volume of the sphere, we need to know the radius of the sphere. So our goal is going to be to solve for r. All right? Because we need to know that. All right? So now, here we go. So I know that if I was trying to solve for r, this is what I would do. So I'm going to just like clean this problem up. So I know that I can get rid of these pi's, right? Because if I want to isolate r over here, let's say I want to isolate this r squared over here, right? I got 12r squared times pi. I also got 4/3 times pi times r to the third over here. I can get rid of these pi's by just doing division. So I can divide the pi's and get rid of them. So divide that pi and divide that by pi. But actually, really, let me show you the long way. Let me show you what I'm actually doing. I don't want to skip any steps here. So, the opposite of multiplying by pi is dividing by pi, or multiplying by the reciprocal of pi, which is 1 over pi. So that means I'm going to do this. Multiply this side by 1 over pi, and multiply this side by 1 over pi. So I'm going to do that, and that, and that, and that. And now we have r squared times 12 is equal to 4/3 r to the third, right? Now, I want to clean this up because typically there will be a number in front of a variable, not a variable in front of a number, all right? So I'm going to just rewrite this. I'm going to just switch this around. And I can do that because of the commutative property. Just like 3 times 2 equals 6, 2 times 3 also equals 6. The order of numbers in multiplication does not change the product of that multiplication. So now we got 12r squared is equal to 4/3 r to the third. All right? So now, I want to get r squared by itself. So now what I'm going to do is, actually, instead of dividing by 12, I could also get rid of the 4/3 if I wanted to. We have options, right? I could either get rid of this 12 and get the r squared by itself, or I could get rid of this 4/3 and get the r to the third by itself. Because remember, my goal is to solve for r, right? I want to solve for r. Okay? So now, I think what I'm going to do is, I'm going to just multiply by 3/4 because that's the reciprocal of 4/3. So I multiply by 3/4 on the right. I multiply by 3/4 on the left. These 4's cancel out. These 3's cancel out. Now, what's 3/4 times 12? 3 times 12 is 36. 36 over 4 is 9. So this becomes 9r squared is equal to r to the third. Now, I have an r squared on the left and an r to the third on the right. I need to combine those r's, right? And have all those r's on the same side. So I want to get all the r's on the same side. So in order to get rid of this r squared over here, I want to do the opposite operation. So the opposite of multiplying by r squared would be dividing by r squared. So I divide by r squared on the left side, and then I divide by r squared on the right side. So I got divide by r squared and divide by r squared. So now I have 9 is what I'm left with is equal to r. So my radius is 9, right? Now, remember, in the beginning of this problem, it said a cylinder and a sphere. A cylinder and a sphere have the same radius and volume. So if I find a radius for one of them, I automatically found a radius for the other one. So I know the radius of the cylinder is 9, and the problem is that they got the same radius and the volume, and the same volume. So the radius of the radius of the sphere is also 9. So that means 9 should go here where r is, and 9 should go here where r is, and everything should equal up, right? But now, the question is, what is the volume of the sphere to the nearest whole number? So now I just go back to the formula for the volume of the sphere, because I can use the formula now because I know what the radius is. Before, I didn't know what the radius is. I had to figure out the radius so I could use the formula. Formulas are great, but you can't use formulas unless you have the required information. I can't use the volume of a sphere formula if I don't know what r is. I know 4/3 is a constant. That's a number. I can use that. I know what pi is. That's 3.1415926 forever, whatever. It goes on forever, right? I know that. Or I could just round it to 3.14, like Pi Day, March 14th and all that, right? But if I don't know what r is, I can't use this formula. But if I know what the volume is, I can solve for r. And I didn't explicitly know what the volume was, but what I did know was, I knew that the volume of this sphere was the same as the volume of this cylinder. So again, cylinder and sphere, they're equal to each other. So we got to take the information from the problem and create an equation. So I created this equation right here. because I knew that they were the same. And my goal was to solve for the radius. And once I know what the radius is, and I know the radius of each of these is the same, then I can go and solve for the volume. And now that's what I'm about to do. So now, V is equal to 4/3 times pi times r to the third. Now, let me also give you this hint. Whenever you're doing problems that involve circles, spheres, or any formula that includes pi, right? If the word problem says to provide the answer, like it says, what is the volume of the sphere to the nearest whole number? If it says that, that is a giveaway that you need to convert pi to 3.14 or just use the pi button on your calculator. Either way. All right. So, but if it doesn't say that, if it doesn't explicitly say to the nearest whole number or to the nearest tenth or round your number to some place value, then that means that you can leave your answer as pi. And also, if you see a question like this on a standardized test, whether it be the SAT, the ACT, or something like that, it just unless you look at the multiple choice questions, and if all those answers have the letter pi in them, then that means, oh, well, I don't got to change pi to 3.14. I could just leave pi. And that means you would only have to multiply 4/3 by the radius to the third power using the order of operations. So, all right, so anyway, 9 is my R, so I'm going to have 3.14, and then I'm going to have 9, and then to the third power. All right, so I'm going to do 4/3 times 3.14, and then 9 to the third power. So 9 times 9 is 81. 81 times 9, I believe, is 729. That's right, Nassim? 729. All right. Yo, Nassim, do this math for me real quick. I don't got my calculator on. So yeah, do the 4/3 times the 3.14 times 729. Let me get that.
3,052.
Is what?
3,052.
It came out like that, or you rounded it?
It came out like 3,000. Well, 3,052.08.
30. So it came out like this: 3,052.08. You sure? Run it back. Run it back. That's what we sure. Double check it. So 3,052.08, and then it says to the nearest whole number, right? So if it's to the nearest whole number, then what does that mean? That means I got to knock off these decimals, right? That's good? So we got 3,052. Now, we need units, though. We need units. We can't just leave it as 3,052. Our units are centimeters. 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 And whenever we deal with volume, our units are to the third power. When we deal with area, our units are to the second power. When we deal with perimeter or something that's one-dimensional, our units are to the first power. So if we were trying to find the perimeter of a rectangle, let's say, we would just have centimeters as our units. If we were trying to find the surface area, we would have centimeters squared. But since we're trying to find the volume, we have centimeters cubed. So this is the final answer, 3,052 cubic centimeters. Now, what if I wanted to check my work? If I wanted to check my work, how would I even do that? I could check my work by going back into the problem and taking this answer, making sure that it makes sense. Because if the volume, it says that the volume of the cylinder and the sphere are the same. They have the same radius and volume. So therefore, if the volume of the sphere is 3,052, then it should follow that the volume of the cylinder should also be that. So that means I should be able to find the volume of this cylinder, and that means 3,052 should be equal to 3.14 times 9 squared times 12. Now the question for us is that true? Is 3.14 times, bro, you should be doing this. 3.14 times 81 times 12. So 3.14 times 81 times 12. Tell me what that is. Three 3.14 times 81 times 12.
It's the same thing.
So the right side equals 3,052, and the left side equals 3,052. So that's proof that our answer is correct. All right? So, again, this is a word problem. Like I said, the first step is to not be intimidated. You got to attack these word problems. You got to be aggressive with them. You have to attack them. You have to have confidence. But the confidence comes from doing a lot of the problems. The confidence comes from doing a lot of the problems. You may have some anxiety when you first read a word problem, but that anxiety will be canceled out by your confidence. But then your confidence only comes from doing a lot of practice and doing a lot of problems. So if you're in class or your teachers are sending online assignments, don't just do the bare minimum. Don't just do the one problem that they send you and then be like, okay, I'm done. Nah, you need to keep doing problems because you can't escape this, right? You can't escape this. In any math class you encounter, you will have word problems. Any standardized test you take, there will be word problems. So if you become more comfortable with word problems, you'll be able to approach the word problems a certain way, and then you'll learn how to do them. So then you'll see them, you'll see different word problems, and you'll recognize, oh, that's one of these joints. Okay, so when I see this, then I know I need to do this. Okay, but that only comes from practice. So just do as many word problems as you can. Remember, you're just translating. You translate from the information from the word problem into an equation. Make sure you know your formulas. And I know it seems like a lot right now, but over time and over practice, it's going to become much more manageable. But you have to do the practice. You have to do the practice. There's no shortcut. I want to repeat that. There is no shortcut. You have to do the practice. Somebody can teach you how to do it, but then it's up to you to actually practice so that you commit the process to memory. And then you actually know how to do it. All right? So, thank you for tuning in. Please continue to send your problems to the All This Math DM, and your problem that you send in might make it to this board, depending on the demand for problems to be completed. And I'll see you soon. Peace.